Hello friends, our next topic is generation of double-sideband suppressed carrier. As we know that the double-sideband suppressed carrier is obtained by taking the product of carrier and message signal. So here for the generation of double-sideband suppressed carrier we call a product modulator, and a ring modulator is the most useful product modulator, also called a chopper modulator. And the circuit of ring modulator is shown in figure. The ring modulator consists of 4 diodes D1, D2, D3, D4. These 4 diodes are connected in such a way that they form a ring. And the direction of ring is from A to B, B to C, C to D and D to A. So the closed ring consists of D1, D3, D2 and D4. Also in this ring modulator, there is a center tap transformer denoted by T1 and T2. The input of the ring modulator is message signal MT and carrier wave CT. Here all the 4 diodes are controlled by a carrier wave. Here the carrier wave is a square wave type. The frequency of the carrier wave is FC and it is applied across the center tap transformer. So we can say that the diodes are controlled by a carrier frequency of the square wave. Now we discuss the operation of ring modulator. The output of a ring modulator is S function of T and it is equals to product of message and carrier. When there is no message, we get 0 output, but when we apply a message, then we get a output in the form of product, that is MT into CT. For our simplicity, we take a sinusoidal message signal and taking a positive half cycle of a message signal and negative half cycle of the message signal. And in both the cases, the diodes are controlled by a carrier wave. So in both positive half cycle of message and negative half cycle of message, we take 2 cases. In first case, we take a positive half cycle of the carrier, and in second case, we take a negative half cycle of the carrier. So we consider individually. First we consider a positive half cycle of the message signal. In this, we consider first case, that is positive half cycle of carrier. Here the input, that is message signal, is positive and carrier is also positive, so diode D1 and D2 are in forward bias or switch on, whereas the diode D3 and D4 is switch off or reverse bias, and correspondingly we get a positive output at transformer T2. And in second case, when message is positive, we apply a negative half cycle of the carrier. In this case, D3 and D4 are forward bias or switch on, whereas D1 and D2 are reverse bias or switch off. In this case, we get a negative output at transformer T2. Similarly, we consider a second situation where we take a negative half cycle of the message signal and we apply a positive half cycle of carrier, that is case 1. In this, the diode D1 and D2 are reverse bias or switch off, whereas D3 and D4 are switched on, and accordingly we get a negative output at transformer T2. And in case 2, when we consider negative half cycle of the carrier, the diode D1 and D2 are forward bias and D3, D4 are reverse bias or switch off, and we get positive output at transformer T2. This operation of a ring modulator strictly follow a product rule, that is output S function of T is equals to product of message signal and carrier signal. That is shown in a form of table. In the ring modulator, we consider a carrier that is of square wave, and in Fourier series, the square wave carrier can be represented as C function of T equals to 4 upon pi summation n equals to 1 to infinity minus 1 to power n minus 1 upon 2n minus 1 cos within bracket 2 pi fct within bracket 2n minus 1. So this is a representation of a square wave carrier in Fourier series, and the output of the ring modulator is the product of message and carrier, and accordingly the output of a ring modulator can be represented in the form of square wave carrier mathematically. This ring modulator is sometimes called a double balanced modulator because it is balanced with respect to both message signal and square wave carrier. Next, we represent a waveform of a ring modulator. Here we consider a arbitrary message signal, but it is of a sinusoidal one, taking positive half and negative half, and the carrier wave is a square wave. The output of a ring modulator is product of message and carrier. So, for the first pulse of a square wave carrier, it is multiplied by a positive half cycle of a message, we get a positive output. This is obtained when diode D1 and D2 are on. This first positive pulse of the carrier is followed by a negative pulse, that is multiply a positive half cycle of message signal and we get a negative output. This negative output is obtained when diode D3, D4 is on. So accordingly, we get a output of the ring modulator. We get positive portion when diode D1 and D2 on, and we get a negative portion when diode D3, D4 on. And here we get a phase reversal or 180 degree phase shift at zero crossing. So for the generation of double sideband suppressed carrier, we use a product modulator, and a ring modulator is a type of product modulator that is widely used, and the output of the ring modulator is double sideband suppressed carrier, and there is a phase reversal at zero crossing.